Okay, students, my name is Palak Patel. I'm working in the Mahatma Gandhi Institute of Technical Education and Research Center, Navsari, in a civil department. Okay, I'm going to teach you design of the structure, and these are subject code 3150612. This subject in a third year, SEM 5th. And today we are going to learn introduction portion. Okay, so shall we start? So first of all, content. What is the content? Overview of the subject. First of all, we are going to learn what is in this subject. What we have to understand and what we have to learn by this subject. So first of all is introduction, unit 1. In the unit 1 we are uh, learn the properties of material, load and load combination, important Indian standard code for civil engineering, method of analysis, strain stress curve and design philosophy. So first of all we have the overview of the subject. So overview subject we have first unit 1 introduction. Unit 1 we have properties of reinforced concrete and structural steel. So first of all in the introduction we are going to learn properties of material like reinforced concrete and structural steel. Then after load and load combination, method of analysis, course and specification and design philosophy. So these all are in the unit 1. Then second is unit 2, philosophy of limit state design for RC structure. So in this subject we have limit state design. We are going to learn limit state design. These are the two methods of limit state design. Limit state design of collapse, limit state design of serviceability, then after partial safety factor for material and loading, stress strain characteristic of concrete and reinforcing steel, neutral axis, bond and anchorage, and development length and splicing. So these are the completed of unit 2. After complete unit 3 we are starting limit state design of RC structural elements. So what are the RC structural element we are going to design in this subject? A beam. So first we are going to learn a beam. So in this subject we are learn a beam types are singly beam, doubly beam, then after T beam, cantilever beam and continuous beam. Okay, in the beam then after we have a slab. So with the slab we are going to learn one-way slab, two-way slab, and then after continuous slab, and not the least cantilever slab also we have. Then after design of column, in the design of column only one type of column we have, short column with axial loading, only one type of column. Then after design foundations, footing design we are learn pad footing, slope footing and combined footing. In combined footing we have two more footings. One is a rectangular footing and rectangular combined footing, and second one is trapezoidal combined footing. Only four types of footing we are going to learn. So these are the only RC structure element design. Then after unit 4, limit state design for steel. While we are starting a design of the steel, we are going to understand type and behavior of steel section, type of steel structure, type of steel structural member, limit state of strength and serviceability, after bolted connection and welded connection. Then after type and behavior of steel section means I section, C channel, L angle, or plate or rolled girder, or this type of steel sections we have. Then after steel structure, so in the steel structure we understand a building, industrial building, roof, truss, girders. It's called a steel structure. Then after steel structural members mean the tension member, compression member, torsion member, then beam column, and column base. So this type of steel structural members. I am only giving a brief detail about it this time, okay? While we starting a unit 4, we are going to learn a unit 4. At that time, I will describe all the thing in a detail, okay? This is just an overview of the subject, okay? Then after bolted connection, in a bolted connection we have a lap joint, butt joint, and then welded connection, fillet weld, groove weld. There are many more types of welded and many more types of bolted connection. We are going to learn all the things. Then after unit 5, unit 5 is a limited design of steel components. What are the steel components? Tension member, compression member, beam column, and column base. We are going to design all the things and analysis also. So you see there is a 5 units we have, 1, 2, 3, 4 and 5. We have 5 units, but these are too lengthy subject. You can understand there is a design tension member, design compression member, both are too lengthy, okay? Same thing while we design a foundation, it will take I think if calculate a 6-minute lecture, it will take a month for a complete a foundation. So in this subject we are going little bit far, little bit speed up, okay, little bit faster. So you just understand what we are doing in this subject. You just write it down all the things in your own words, in your languages. आपको जो लैंग्वेज समझ में आ रही है उस लैंग्वेज में लिख लो, चाहे तो हिंदी में लिखो, गुजराती में लिखो, अपनी लैंग्वेज में लिखो। मैं जो बोल रहा हूँ समझ में आ रहा है उस हिसाब से लिखो, या तो ये पूरी की पूरी पीपीटी कॉपी कर लो। आपको क्या करना है, ये लिखना, यू जस्ट नोट डाउन ऑल द थिंग्स। आई जस्ट ओपन दिस पीपीटी, ये स्लाइड ओपन हुई आपकी, आपने पॉज किया, ये सारे डेटा लिख लियो। उसके बाद देन आफ्टर यू प्ले अगेन एंड लिसन व्हाट आई एम सेइंग। इफ यू listen anything important in my words, you just write it down. Write it down in a sentence, in a word, anything else. How can you remember is important. Okay? Write it down all the things. I hope you bring a notebook with you. Okay? These are the overview of the subject. Then after introduction. The first chapter we started here, introduction. First of all, properties of material. Then as reinforced concrete, first material is reinforced concrete made by a two material, concrete and reinforced steel. We have a two material, concrete and reinforced steel. Both concrete and reinforced steel behave like one material while applied a load on a structure. So reinforced concrete is made by two material, concrete and reinforced steel. Both property have different. Both have a different properties. Like load carrying capacity are different. But while we applied a load on the structure which is casted with reinforced and concrete both material, then these two material behave like one material. Understood? Okay. So first of all, we have a properties of concrete. Properties of concrete is depend on a used material like cement, sand, aggregate, water, etc. Properties of concrete is depend on curing method, compaction method and type, environment condition, etc. Then after a compaction state of concrete, the compaction state of concrete is depend on the grade of cement. So what is the grade of cement? If I am saying I am taking a M50 grade of cement, the market. So I can explain there is a concrete compressive strength in 28 days in Newton per mm square is 15. How can I define it? How can I describe it here? If I have a M20 grade cement, I am casting M50 grade cement, M50 grade cement with a reinforced concrete in a cube, and after a 28 days of curing, I am going to test the cube which are used material by a M50. I am going to test the cube. At that time, testing result, a compressive strength of the cube is 15. Same thing here. M10 is a 10, M20 is a 20 compressive strength, M25 have a 20, M30 have a 30, M55 have 50, M70 have 70 compressive strength. Write it down all the details. If you don't have to remember all the things, you will recognize easily. If I am asking in sometimes I am going to buy a M50 grade cement, so what is the compressive strength of the concrete? You have answer, there is a M50 grade cement, the compressive strength is 40. Sorry, I just M40 grade cement, the compressive strength is 40. Okay, understand? If I am asked what is M30, what is M30 grade cement? So what is defined by 30? So 30 is compressive strength of concrete in 28 days in Newton per mm square. Okay, understood? Next, properties of material. There is a tensile strength of concrete. To estimate tensile strength from the compressive strength, the following formula may be used. Here is FCT 0.7 under root FCK. So what is FCK? FCK is the compressive strength of concrete in Newton per mm square, and FCT is equal to tensile strength of concrete. These are the equation. FCT is equal to 0.7 under root FCK. Okay. The tensile strength of concrete is so less compared to compressive strength. Is so less compared to compressive strength. If I am saying that there is a concrete, I am create a structure which are beam. I am applied a load on a beam is a tension force. I am applied a load is a tension force on the beam. That time the concrete will be fail because its tensile strength is so less compared to compressive strength. ओके, समझ में आ रहा है? जो डिफरेंट सिंपल वर्ड में बोलूँ कि आपका कंक्रीट जो है वो टेंसाइल फोर्स रेजिस्ट नहीं कर सकता, वो टेंसाइल फोर्स में फेल होगा. ओके, मगर वो कंप्रेसिव फोर्स रेजिस्ट कर सकता है, लेकिन वो टेंसाइल फोर्स में फेल होगा. That's why we assign a steel. We assign a reinforced steel in the concrete to resist a tensile force. ओके तो हम इसीलिए रेनफोर्स स्टील असाइन करते हैं कंक्रीट के अंदर, ताकि वो जो टेंशन फोर्स है जो कंक्रीट कैरी नहीं कर रहा सकता उसे स्टील कैरी करता है. ओके ये चीज़ आपको तब समझ में आएगी जब हम डिज़ाइन करेंगे. जब हम बैलेंस सेक्शन, अंडर रेनफोर्स सेक्शन और ओवर रेनफोर्स सेक्शन जब सीखेंगे, जैसे न्यूट्रल एक्सिस के बारे में सीखेंगे, तब आपको ये चीज़ समझ में आ जाएगी कि हम रेनफोर्स स्टील क्यों असाइन करते हैं. ओके समझ में आया? सो इजी, अंडरस्टूड. देन आफ्टर नेक्स्ट इज प्रॉपर्टीज ऑफ मटेरियल, प्रॉपर्टीज ऑफ रेनफोर्स स्टील. Properties of reinforced steel. So reinforced steel shall be any of the following: mild steel and medium tensile steel bar, which this we are used in the construction, mild steel or medium tensile steel bar. Then we have to follow IS 432 part 1 when we design high strength deformed steel bar in a construction or in a design. We have to follow IS 1786. So IS means Indian Standard Code. Okay, Indian Standard Code. Hard drawn steel wire fabric. When we use this type of wire in the construction, then we have to follow IS 1566. And while we are constructed a steel structural steel grade A of, then we have to follow IS 2062. Okay, these are the properties of reinforced. You will find all properties of steel from this code. For the mild steel, you will follow IS 432 part 1. You will find all the properties of mild steel and medium tensile steel bar from this IS code. Same for the all. Okay. Then after this are some precaution. All reinforcement steel shall be free from loose rust, coat of paints, oil, mud or any other substances which may destroy or reduce bond. That means if reinforcement steel have a coat of paint or oil or any other substances which are the causes for the bonding between reinforcement steel and concrete. That means these substances, oil or mud or coat of paint will be effect on the bond between reinforcement steel and concrete. ओके अगर आपके reinforcement स्टील के ऊपर अगर कोई पेंट लगा हुआ हो, कोई ऑयल लगा हुआ हो या कोई मड लगा हो, कोई ऐसा कोई कादो कीचड़ कुछ लगा हुआ हो, कोई ऐसी इम्प्योरिटीज हो, तो वो स्टील आपके कंक्रीट के साथ बॉन्डिंग नहीं कर सकता. समझ में आया? तो ये प्रिकॉशंस है रेनफोर्समेंट स्टील यूज़ करने के. आपको इन चीज़ों का ध्यान रखना होगा. ये तो साइट प्रिकॉशन है. ओके. देन आफ्टर मॉड्यूलस ऑफ इलास्टिसिटी ऑफ स्टील shall be taken as 200 kilonewton per mm square. Note it down. Modulus of elasticity is denoted by capital E. Okay. Then after structural steel, the steel commonly used in a steel construction, namely structural mild steel and high tensile structural steel. So what is a structural steel? Structural steel means steel which we are going to use in a steel construction, steel building or any other industrial building. We are going to use a steel which called a structural steel. सिंपल वर्ड में बोलूँ तो अगर आप किसी स्ट्रक्चर बिल्डिंग बना रहे हो, कोई स्टील बिल्डिंग बना रहे हो, वहाँ इस्तेमाल होने वाले मटेरियल को हम स्ट्रक्चरल स्टील कहते हैं. So which type of structural steel we have? We have a I section, C channel, L angle. Then after some plates, or then after rolled section we have also. So this type of material member we call as a structural steel. Simple definition here is. And then after physical properties of structural steel, just note it down on your notebook here. Okay. Unit mass of steel rho is equal to 7850 kg per meter cube. Modulus of elasticity capital E is equal to 2 into 10 raised to 5 Newton per mm square. Poisson's ratio mu is equal to 0.3. Then after modulus of rigidity G is equal to 0.769 into 10 raised to 5 Newton per mm square. Coefficient of thermal expansion alpha 1 is equal to 12 into 10 raised to 6 1 by C degree. So these are the physical properties. These are the physical properties. Will never change. It will never change. Then after mechanical properties of structural steel, we have two properties: yield stress Fy, tensile stress and ultimate stress Fu. These both properties will be changed while we changing a carbon portion. Okay, so this Fy and Fu will be changed. Then second, we have a load and load combination. A structure is subjected to various types of load like dead load, live load, wind load, snow load and earthquake load. These are the 5 types of load will be resisted by a structure in their whole lifespan: live load, wind load, snow load and earthquake load. That is dead load also. So first of all we are going to understand the dead load. So dead load, this consists of a weight of wall, partitions, floor, roof, including the weight of all other permanent constructions in the buildings. All other permanent construction of the building. Understood? There is a permanent construction on the building we call as a dead load, like a slab, roof, floor, beam also has a self weight, so we call it as a dead load. So these are some unit weight of the building. Then brick have a 60 kN per meter cube. Cement has a 12.5 into 40.1 kN cube. Cement mortar 20 kN cube. Cement concrete 24 kN cube. Cement concrete 25 kN cube. Cement plaster 20 kN cube. Then after some stone ballast 70.2 kN per meter cube. aggregate 70.5 kilonewton per meter cube, granite 24.5 kilonewton per meter cube, marble 26.5 kilonewton per meter cube, timber 5.1 to 6.25 kilonewton per meter cube, plastic 12.5 kilonewton per meter cube, and rubber 30 kilonewton per meter cube. I will inform you something that you don't have to remember all these values. आपको ये कोई भी वैल्यू रिमेंबर नहीं करनी है. You don't have to remember all this value. You will find this value from IS Indian Standard Code 875 Part 1. IS 875 Part 1. You will find all the values of this unit weight of building material from this code. Okay, I am just giving some important material which we are using these days, but in this code we have lots of materials. You just read it. We have the all that are material in this code. Okay, then after we have a live load on the floors. Live load on the floor change the various types of the building. Means your live load will be changed while we are changing the types of the building, but dead load never change. The minimum live load on a different floor for the different uses as given in the table. So dead load we have a table, same as live load we have a table. First of all, you have understand some terminology. Imposed load, the load assumed to be produced by a intended use or occupancy of a building, including weight of movable, distributed, concentrated load due to impact and vibration. Okay. Means imposed load will be changed by the occupancy of the building and use of the building. Okay, imposed load in a simple word I can say it's LIVE. Sorry. Live load. Sure. You understand imposed load? Then after assembly building, then any building or a part of a building where group of people gather for a similar purposes. For example, theater, assembly hall, city halls. Then after business building, any building or a part of a building which is used for the transaction or a business for a keeping of accounts and records for the similar purpose. While I are informing about some building details, because there is a live load on the floor changes of various types of the building. मतलब ये हुआ कि अगर बिल्डिंग की टाइप्स चेंज होगी, बिल्डिंग का यूज़ चेंज होगा, तो आपका लाइव लोड चेंज होगा. तो जब आप डिज़ाइन कर रहे हो तो आपको पता होना चाहिए कि आप कौन सी बिल्डिंग डिज़ाइन कर रहे हो, असेंबली बिल्डिंग डिज़ाइन कर रहे हो या बिजनेस बिल्डिंग या ऑफिस बिल्डिंग. सो अगर ये टाइप्स ऑफ बिल्डिंग और यूज़ ऑफ बिल्डिंग चेंज हो गए तो आपके लाइव लोड भी चेंज हो गए. दैट्स वाई आई एम जस्ट गिविंग यू द इंफॉर्मेशन about building, which type of building we have. Then after office building, Office purposes including the purpose of administration, clearing work, handling money. The building primarily to be used as an office or for office purposes. There's a little bit difference between business building and office building. Business building used for the keeping of account and records, then office building used for the handling money. Then after education building, this shall include any building used for school, college or daycare purposes. So what are industrial building? Any building or part of building or a structure in which products or material of various types and properties are fabricated, assembled and processed. Understood in the what is industrial building? Where industrial building means which we are used for the product some material. Okay. Then after institutional building, any building or a part of building which is used for purposes such as medical or other treatment in the case of persons suffering from physical and mental illness like hospital, jail and prison. Then residential building, any building in which sleeping accommodation is provided for normal residential purpose with or without cooking or dining or both facilities like apartment, restaurants and hostels. So what is a residential building? Residential building means a simple use for the sleeping, for the resting or any other type of work we are going to use in the residential building like sleeping, resting or many more. So and then after we are starting which livelihood we have first a residential building, dwelling house. All rooms and kitchen have a 2 km per mm square UDL. Toilet and bathroom have a 2 km per meter square. Corridor and passage have a 3 km per meter square. Balcony have a 3 km per meter square. Hotel, hostel, residential clubs. In this type of building, living room and bedroom have a 2 km per meter square. Kitchen and laundries 3 km per meter square. Public lodge 3 km per meter square. Storeroom 5 km per meter square. 4 km per meter square. Office room 2, room 3, bath and toilet 2, corridor and passage and staircases register 3 km per meter square. Balcony 4 km per meter square. Then after garages have vehicle not exceed 2.5 ton gross weight. Then we have a UTL 2.5 km per meter square. Vehicle not exceed 4 tons gross weight. Then UDL 5 km per meter square. Education building, classroom, dining room, office, projection room, kitchen, toilet, bathroom, storeroom, balcony, all the things. Then after in the library, stick room here, look at here, 6 km per meter square for the minimum height 2.2 meter. Means if height minimum is 2.2 meter, then we use a 6 km per meter square UDL load, live load. And when the height beyond 2.2 meter, then we have 2 km per meter square per meter. Then after reading room reading room with separate storage, corridor, passage and staircases, assembly building, assembly area with fixed seat, we have the 4, assembly area without fixed seat, 5 km per meter square. Then after restaurant, museum, art galleries have 4, projection room 5, stages, dressing room, toilet, corridor passage for the wheel like a trolley, we have 5 km square, balcony resist 4 km square. Then business and office building, rooms for general use, rooms without separate storage, machine room, storage space, cafeteria, kitchen, corridor, bath and toilet room. Then industrial building without machinery 2 km square, with machinery light duty 5 km square, medium duty 7 km square, heavy duty 10 km square. Storage building we have a 2.5 km square per each meter of height with minimum 7.5 km per meter square. Means in this line we can say that we have to take 7.5 km square, it's a minimum, but if height will be more, then we have to multiply by height by 2.4 km square, and whichever value we got we have used as a live load. Understood? If this value while we are multiplied by a 2.4 with the height, and if we value lesser than 7.5 km square, we will take live load is 7.5 km per meter square. Then after reduction of floor on live load, the following reduction assume. We assume this type of load will be reduction while we going a floor height, while we are increase a floor height. So in this table you can say there is a first floor there is 0% reduction, second floor 10% reduction, third floor 20% reduction, fourth floor 30% reduction, and 5 and more we get reduce 40% reduction. So these are the assume. Look here, these are the assume, means you not need to follow all this reduction, it's just the assume. Okay, no reduction shall be made in a case of live load more than 5 km per meter square. If live load is more than a 5 km per meter square, no reduction shall be made. Okay, like warehouses, garages and any other buildings which use for the storage purpose. Understood? Then after a live load on a roof, on a flat roof, sloping roof and curved roof allows live load as per table. The live load given below do not include loads due to snow, rain and dust collection. Then roof shall be designed for the live load given below or snow load, rain load, whichever is ग्रेटर. ओके, मतलब कि नीचे जो ये टेबल दी हुई है, इस टेबल के अंदर ये जो लोड दिया हुआ है उसके अंदर सिर्फ लाइव लोड है, उसके अंदर इन दिस वैल्यू नॉट इंक्लूड स्नो लोड और रेन लोड, इट्स नॉट इंक्लूडेड in this table. Okay, and while we are designing a roof, we calculate a live load as well as snow load and rain load we also calculated, and whichever load is greater, whichever load is maximum by these three values or two values, we will take as a live load. We will design the roof by this load. Okay, मतलब कि इस लाइव लोड, स्नो लोड और रेन लोड तीनों को कैलकुलेट करने के बाद जो मैक्सिमम लोड होगा उस लोड को हम डिज़ाइन लोड के रूप में लेके रूफ को डिज़ाइन करेंगे. ओके, अंडरस्टूड. Then after this table is here, flat, sloping or curved roof with a slope up to and including 10 degree. If SS provided, then live load will be 1.5 kg per meter square. If SS not provided, except for the maintenance, we have a live load 0.75 kg per meter square. And second, sloping roof with a slope greater than 10 degree, 0.75 km square less or 0.02 km square for every degree increase in slope over 10. Understood? These are the completed of live load. So first of all, I will tell you what is a live load. You can not have to remember all this data like a dead load. In the dead load हमें कोई भी डेटा याद नहीं रखने थे, रिमेम्बर नहीं करने थे. सेम थिंग लाइव लोड में होगी. लाइव लोड में आपके ये सारे टेबल रिमेम्बर करने की ज़रूरत नहीं है. ये सारे लोड यू विल फाइंड इट फ्रॉम IS 875 875 part 1 for the dead load and IS 875 part 2 for the live load. Understood? These two code you have to download from the Google or search it on the Google, you will find it and download it. Okay. Then the second is wind load terminology. Okay, its time is completed. So this wind load we will start in the next lecture. Okay. So remember all the things. I hope you write it down all the datas and remember all the things, revise it and practice all the things. In the next lecture we will starting from here, wind load terminology.